Hello students, so we continue with our topic on laws of motion. Before we go on to the next topic on speed and velocity, I would once again revise what is distance and what is displacement by giving a few more examples. Students, while explaining, please concentrate on the terms because there are some terms which are new to you in science. For example, you will come across words like acceleration, momentum, then inertia. There are quite a few terms which you will be probably hearing for the first time, and you need to get acquainted or used to hearing these scientific terms, right? I will make you understand the meaning of the terms in very simple language. Now let us continue with our topic on distance and displacement. I will repeat both the definitions for you right now. Then again, with the help of illustrations on the board, we will clear the concept of distance and displacement, and then we will proceed further, right? Now students, yesterday you saw that the distance is the length of the actual path traveled by an object or a body when it moves from one point to the other, right? So that is the meaning of distance in scientific terms. And displacement is the minimum distance between the starting point and the finishing point, right? And the minimum distance, students, please remember, minimum distance between any 2 points is always a straight line joining the 2 points, and that is displacement, right? I even yesterday told you that when motion takes place in a straight line, then distance and displacement values will be the same. If motion is not along a straight line, you will find that the value of displacement is always lesser or smaller than the value of distance. Yesterday we saw so many of those examples of students going to school or elsewhere where you saw that the value of displacement is less than the value of distance. In order to reinforce and to clear or clarify your idea on distance and displacement, we will take up some more examples. Please remain focused on hearing and on the lecture. You will be able to understand, right? So we will take up some more examples. So students, let's take up some few examples so that you'll understand distance and displacement at the same time. First, again, we'll talk about motion which is not in a straight line, right? So let us take an example of a person, let us say, starting from point A. So here you have a person starting from point A, right? So a person starts from point A. Let us say the person goes 4 meters up to point B towards the east. I told you you have to remember directions because when we talk about displacement, displacement involves the component of direction, right? While specifying displacement, direction is involved. So you have the north, the south, the west and the east. These are the directions which you normally use. Now the person has started from point A and moves 4 meters. I am now using meters because meter is the SI unit of displacement, right? And distance as well. So a person moves 4 meters towards point B, right? After that, the person, after reaching point B, the person goes up to point C. right? Covering a distance of, let us say, 3 meters. These are all just numerical examples so that you will understand. So the person starts from point A, reaches point B, then turns northward and travels a distance of 3 meters. Now the person is positioned at point C, right? So now let us see the distance covered by the person. So the distance covered by the person is the actual length of the path along which the person has traveled. The person has walked on this road to reach here, right? So this is the actual path followed by the person. So the distance will be the length of the actual part, that is AB plus BC, and AB plus BC is equal to 4 meter plus 3 meters, right? So the distance traveled by the person right now is 7 meters, right? So the first situation is that the person is stationed right now at C. Now let us understand what is displacement. Students, I told you the displacement is the minimum distance between the starting point and the finishing point. Now the starting point is A, the finishing point is C. So the minimum distance between any 2 points, whether the road is like this or whether the road is curved, whatever be it, the minimum distance between any 2 points is always a straight line joining the 2 points. So in this case, the straight line joining the 2 points should be here, like this. So this will be the straight line joining the 2 points, right? So that means the displacement is AC. If you calculate, let's say, you will find it is 5 meters. So this is distance, right? This is distance, and this AC equal to 5 meter. AC is the displacement because it is the minimum distance between the starting point and the finishing point. So AC is equal to 5 meter. Did you understand? Right? Now if you look at the value, see here motion is not in a straight line. This motion is not a straight line motion. Even these motions are not a straight line motion, right? You can call this motion as a straight line motion along a straight road. We will come to that later. So for right now, students, please remember that this is the displacement. Now you saw displacement is the minimum distance between starting point and finishing point. So this is 5 meters which we have, right? Now let us say, students, see here you have seen that the value of displacement when motion is not in a straight line, the value of displacement is always less than the value of distance. Distance covered is more, na? 4 meter plus 3 meter is 7 meter. So right now this person is displaced by 5 meters, right, from its original position. But in which direction? I told you this, I gave you direction: north, south, west and east. So this direction is between the north and the east, so it is northeast position, right? The distance or the position between the north and the east is called as northeast. That all of you know directions. Position between north and east is called as northeast. Position between north and west is called as northwest. Position between south and west is called as southwest. South and east is called as southeast. So right now the person is displaced by 5 meters from its original position towards the northeast. I hope this has now clarified your position. I also gave you an example telling you that suppose this person returns back. Now this person is coming back. So this person is coming back along the same route, let us assume. So the person travels 3 meters from C to B and again 4 meters from B to A. So the person will cover up again 7 meters on its way back, right? I told you now what happens is the person has now, if we talk about a situation where the person has returned back home, then the total distance traveled by the person would be 14 meters, right? 7 meters while going, 7 meters while coming. So this is the total distance traveled by the person. Total distance traveled by the person in going and coming back, right? To and fro. जाके आके totally कितना हुआ? 14 meters, right? 7 meters going and 7 meters coming, that is 14 meters is the going and coming distance. Now let us talk about displacement when the person has reached the original position. So the original position is A. Now the person has come back covering a total distance of 14 meters going and coming. Now what is the person's displacement once the person returns to his original position? Once the person returns to his original position, the displacement will be 0. I told you, initial position is A and final position is A, so the displacement is going to be 0. Displacement is 0 meters when a person comes back to its original position. Yesterday I even gave you the example of a girl moving in a circular track, if you remember, right? So these are examples which should clarify your concept on distance and displacement. Still there are some more points which I would like to bring to your notice so that the point gets very, very clear. Now let us consider motion along a straight line. Let us say the person starts from point A and goes along a straight line up to point, say let us say here, we'll take here, same position. So person has gone A to B, let us say 4 meters, and B to C, let us say the person has gone 3 meters. So what is the total distance? The distance travelled will be 7 meters, right now? Actual path travelled by the person is A to B and B to C. So distance will be the length of the actual path, that is AB plus BC, that is 7 meter. Right? Now students, what should be the displacement? Displacement in this case is also AB plus BC, because this AC is a straight line, and I told you the straight line between joining 2 points is the minimum distance between 2 points. You take any 2 points, there are various ways of reaching it, like this, but ultimately the shortest distance between the 2 points is always a straight line joining the 2 points. So in this case what has happened, distance covered was in a straight line, so the displacement will also be same. So here in this case the distance is 7 meters, right? And displacement will also be 7 meters. Why? Because the motion has taken place along a straight line, right? When motion takes place along a straight line, then value of distance and value of displacement should be a same. In all other cases other than straight line motion, please remember, always in all other motions except straight line motion, the value of displacement will always be greater than the value of displacement will be less than the value of distance. So please, I am repeating once again, if motion is not in a straight line, you saw that example before, right? The displacement was 5 meter and distance was 7 meter. So that was not a straight line motion. So when motion is not in a straight line, value of displacement will be less than the value of distance. Distance will always be greater than displacement if motion is not in a straight line, right? So students, I believe this should clear your concept. I also told you that if the person goes from A to C and comes back from C to A, displacement will be 0 because the person has returned to the original position, just as Swarali had done in a park, right? So students, I hope your concept on distance and displacement has been clarified totally. I have tried my best. I have given you many examples to show you what is the difference between distance and displacement. I made and I stressed a very important point, right? Many important points are there which you need to take note of, right? First is the difference in the definition. What is the difference in the definition? Distance is the length of the actual path traveled by an object when it is going from one point to the other point. And displacement is the minimum distance between the starting point and the finishing point, right? So we saw that when motion is not in a straight line, then distance is always greater than displacement. You saw that 4 meter and 3 meter, which was not in a straight line, the value of distance was 7 meter, but the value of displacement was only 5 meter. So when motion is not in a straight line, the value of displacement is always less than the value of distance, right? If motion takes place along a straight line, the value of distance and displacement will be the same because the minimum distance is also a straight line joining the 2 points, right? So you just now saw that when straight line motion was there, the distance covered was 7 meter and the displacement also is 7 meter, but that is when motion takes place in a straight line. Now students, I must remind you about the units of all these quantities. You have to keep in mind the units as well because these are all important points of learning when you are learning any term related to motion, or for that matter any quantities in physics. Physical quantities in physics need to have their units defined by you and memorized by you. Now since distance and displacement, they are both length measurements, right? You are measuring the length of the path in both the cases. So the SI unit of distance is meter. The SI is the standard international unit of displacement is also meter. So the SI unit of distance as well as displacement both are meter. In CGS system, CGS is centimeter, gram and second, right? All these systems are measured in terms of length, mass and time. So in CGS, centimeter, gram, second system, the unit of distance and displacement will be centimeter. But nowadays nobody uses, many a time they always use the standard international system of units, that is SI system is always used. Now students, you will come, when we go to the next topic, you will come to another term, whether quantities are vector quantities or scalar quantities. Probably you learnt about this in your 9th standard, in your 8th standard or 7th standard as well, right? Some of you have learnt it in lower standards. Now let me make the point clear with the help of simple example. First I will tell you what is the scalar quantity. A scalar quantity is a physical quantity which requires only magnitude for its description. Magnitude मतलब न्यूमेरिकल वैल्यू, दिशा का ज़रूरत नहीं है, डायरेक्शन स्पेसिफाई करने का ज़रूरत नहीं है. ऐसा फिजिकल क्वांटिटीज, सच फिजिकल क्वांटिटीज आर कॉल्ड एज स्केलर क्वांटिटीज. I repeat, physical quantities which require only magnitude or numerical value for their description are called as scalar quantity. Now let me give you an example. Your sir, Almeida sir, is 6 feet in height, right? My height or length you can say, right? But while describing height, we never talk about length. Height is the same, length measurement only. But to know my height, 6 feet, if I tell you my height is 6 feet, that should be enough for you to understand what my height exactly is, right? Do I have to mention that I am 6 feet in the north direction or 6 feet in the south direction? Do I have to specify direction for describing my height? No. So that means to describe my height, I don't have to describe any direction. That means it is a scalar quantity. So quantities like time, right? Quantities like time, then distance, these quantities are what you call as scalar quantities. There are many other quantities in physics which you will come across. You only require magnitude to describe them. You don't require to specify direction. Now you will learn that when you're talking about speed and velocity, since speed is measured in terms of distance, so speed will be a scalar quantity, because you only have to have knowledge of the numerical value to understand how fast or slow that object is moving. So speed is a scalar quantity. But if you talk about velocity, then we will come to another quantity. Now after scalar quantity, I told you quantities or physical quantities which need only magnitude for description are called as scalar quantities. Example, distance, time, right? You search a few more examples. I am giving it to you as an assignment. Search a few more examples of scalar quantities. You will come to know about it. Even mass is a scalar quantity. Mass, the quantity of matter contained in a person's body. If I tell you that my mass, I'm not talking about weight, mind you. If I tell you that my mass is, let us say, 60 kg, that means telling you 60 kg is more than enough for you to understand my mass. You need not know whether I weigh 50 kg in the east direction, west direction, north direction or south direction. Do you? No. So these quantities are called as scalar quantities. Now students, what are vector quantities? Quantities which require magnitude, that is numerical value, as well as direction for their description. Such quantities are called as vector quantities. I repeat once again, quantities that require magnitude as well as direction for their description, they are called as vector quantities. You will be coming to now, you have learnt about displacement. You must have heard me now saying that a person is displaced by 5 meters towards the northeast, right? Normally when we use word displacement in physics, we don't stress the direction, but the concept of direction is involved in displacement, because displacement takes into account the direction by which an object or a person is from the original position. So when I gave you an example that the person was at C, and I asked what is the displacement, the person was displaced by 5 meters towards the northeast. So quantities like displacement not only require numerical value or magnitude for description, but they also require direction for their description. So physical quantities which are described by magnitude, means numerical value as well as direction, they are called as vector quantity. Displacement is an example of a vector quantity because it involves the direction part also. Students, I believe that you have now completely understood the difference between distance and displacement. The difference between distance and displacement I am giving you right now. You can hear my this lecture and make a note of it in your books. I am repeating it only once, right? Because we have to take up some other topics as well. Now, if you are asked the difference between distance and displacement, let us see what all points we can get. I am starting with the differentiation one by one, right? Now, first difference is the definition. Distance is the length of the actual path traveled by a body or an object when it moves from one point to the other. Displacement is the minimum distance between the starting point and the finishing point or the ending point. Distance is a scalar quantity. Displacement is a vector quantity. This is the second point, right? Then distance is related to speed and displacement is related to velocity, right? Displacement can be zero. You have seen in so many cases how displacement was zero. Distance may or may not be zero. I repeat once again. Displacement can be zero, right? Displacement in many cases, can be zero if the person is returning to original position. So the third point is displacement can be zero, but distance, right, may or may not be zero. Many a times distance is never zero, right? Because distance is the length of the path covered by an object. So if a person doesn't move only, then the distance is going to be zero. So that's why I said distance may or may not be zero, but displacement can be zero. When is displacement zero? When the person returns to the position from which it has started. So these are some of the points of difference between distance and displacement. Students, with this I believe that you would have understood what is the difference between distance and displacement. In my next video lecture, you will cover up the concept of speed and velocity, right? Till then, study, revise the concepts of distance and displacement and take care of yourselves. Thank you.